Okay, we're going to take some notes on combinations and permutations. So a permutation is order matters and you can't repeat. So kind of like the ice cream problem I did, or that was in your homework. If you have 3 scoops of ice cream on a cone, you know, and they're all different flavors, the order is going to matter. For an ice cream cone, you're going to eat them top down. So for a permutation, it's NPR, which N is like N items. That's how many you're choosing from. And R is R at a time. That's how many you're picking. So NPR is equal to N factorial divided by N minus R factorial. And factorial just means multiply it out all the way down to 1. If you've never seen that, an example, 5 factorial is just 5 times 4 times 3 times 2 times 1. So an example here, a student body of 15 wants to elect a president, vice president, secretary, and treasurer. So our question really is, how many ways can this be done? So this is going to be a permutation because 1, they can't repeat, so someone can't be president and vice president. And then 2, order matters because if you pick person number 1 for president, they can't, they're kind of eliminated. Sorry, I said that the wrong way. But you care who's president over versus who's treasurer and vice president. So order is going to matter here. So this is going to be 15 choices, so 15 people, and we're picking 4 of them. So this is 15 factorial divided by 15 minus 4 factorial. So 15 factorial divided by 11 factorial. So 15 times 14 times 13 times 12 times 11 times 10 times 9, all the way down to 1. I wrote out more than you needed to, but you'll see why in a minute. Our denominator is 11 factorial, so 11 times 10 times 9, all the way down to 1. And so here, everything from 11 down is going to cross out in our numerator and our denominator. So we're really just left with 15 times 14 times 13 times 12. And this will always happen, that some of them will cross out. So 15 times 14 times 13 times 12, there's 32,760 ways that it's possible to pick a president, vice president, secretary, and treasurer out of 15 students. And then a combination is order doesn't matter. And you still can't repeat. So this is NCR, and we usually read this N choose R. We have N things, we're choosing R of them. It's still N factorial in our numerator. Our denominator still has N minus R factorial, but it also has another R factorial in the denominator. So 2 parts of the denominator. So an example here, Natalie has homework in 5 classes. she only has time to do 2 assignments, or 2 of them. So we want to figure out how many different combinations this could be. So again, order doesn't matter. She's going to get 2 assignments done. So as long as they're both done by, let's say tomorrow's the due date, then that's what matters here. So this is 5 choose 2. So it's 5 factorial over 5 minus 2 factorial, 2 factorial. So 5 factorial over 3 factorial, 2 factorial. A lot of people will skip straight to this step. And then notice these bottom 2 numbers for a combination are always going to have a sum of the numerator. So here, 5 times 4 times 3 times 2 times 1 over 3 times 2 times 1 times 2 times 1. So 3, 2, 1 all cross out. And we have 20 over 2, which is equal to 10. Yes, there is a button to do this on your calculators. Even the non-graphing calculators have an option for this. But if you're doing this on a homework or a test, I would recommend you show kind of your step. And you don't have to write this whole thing out, but just show that you know what you're talking about. And definitely confirm it on your calculator though.